Hey everyone, welcome to this explainer. We all know our smartphones and laptops are ridiculously complex, right? But honestly, it is so easy to just take that microscopic ballet happening right under the glass completely for granted. Today, we're not just going to sit here and list off a bunch of boring specs. Instead, we're going to literally peel back the layers and demystify the core ecosystem that is actively powering our modern age. Okay, let's dive into this. We've got a really fun roadmap for this top-down journey today. First, we'll look at the body and the mind. Then we'll check out the brain of your computer, and finally, we'll wrap up with the four-step thinking cycle. So let's start right at the top. Moving right into part one, the body and the mind. And to kick off this macro view, we really have to ask the most fundamental question, right? Like, what actually is the real difference between hardware and software?
Well, think of it kind of like a giant book. We can essentially split the entire machine into two distinct halves. The hardware, that's the physical book. It's the tangible paper, the heavy, hardbound cover, the motherboard, all that circuitry you can physically touch. But the software, that is the story written inside. It's the untouchable code, the apps, the completely invisible logic that's actually dictating the plot.
But here's the thing, a physical book with totally blank pages doesn't exactly do anyone much good, does it? Without both the physical body to execute the tasks and the digital mind telling it exactly what to be, a modern computer just cannot exist. They are absolutely 100% interdependent. Let's move to part two, the brain of your computer, and see how this all builds together, because now we're transitioning from that broad body analogy straight into the actual physical anatomy inside the machine. And right at the dead center of this entire ecosystem is the CPU, the central processing unit. This thing is the literal beating heart and the processing brain of the whole operation. It manages these incredibly massive data streams, taking in billions of instructions every single second. Just to put that into perspective, that's roughly the equivalent of reading every single book in your local library in the absolute blink of an eye. It's wild. It tells every single other physical part exactly what to do and exactly when to do it. But here's the catch. It absolutely cannot do it alone. As blindingly fast as that central brain is, if it had to hold every single piece of data in the world all by itself, it would completely choke. It desperately needs a supporting cast. Enter our very first supporting character, RAM, or Random Access Memory. Now, you probably already know this is the computer's short-term workspace, but visually, imagine a tremendously messy room that is just instantly cleared off, giving you a perfectly clean desk to work on right this second. That's RAM. It holds open your active apps so the CPU can reach out and grab them instantly without having to go digging through deep storage. But when you're all done and you actually need to pack things away for good, you turn to the SSD, the solid state drive. Unlike RAM, which, by the way, completely forgets everything the second the power drops, the SSD is your permanent filing cabinet. It's where the permanent story lives. Your files, your photos, the entire operating system, they all live here long term, until the CPU decides it needs to retrieve them again. So, the crucial point here, all of these amazing components, the motherboard, the RAM workspace, the SSD cabinet, they all bow to the CPU. Without that central brain orchestrating those billions of data streams, that super expensive smartphone or sleek laptop sitting right in front of you is, quite literally, just a really expensive paperweight. And this brilliantly illustrates our third and final section, the four-step thinking cycle. Because now we get to see how that body and mind actually move and think in real time. And guys, this is where the magic really happens. Because despite the completely endless variety of tech out there, the foundational logic is totally universal. From those warehouse-sized supercomputers crunching crazy climate models, right down to the smartwatch sitting on your wrist, the underlying rhythm boils down to the exact same four things. Let's rapidly walk through this universal loop. Step one is input. You type a key or tap a screen. Step two is process. The CPU organizes all that raw data using hidden software instructions. Step three is storage, saving it quickly to RAM or the SSD so it doesn't lose its place. And step four is output, flashing the final result on your screen or playing a sound. Input, process, storage, output. It is just a relentless, never-ending loop. Now, what's really interesting here is that the complexity of the task doesn't change the underlying rules at all. Think about it. Rendering a massive 3D video game world, sending a quick text message to your mom, or, I don't know, calculating a rocket's orbital trajectory. It is all built entirely on those exact same four basic steps. Sure, the scale of the math explodes, but the foundation, it never ever wavers. To truly grasp this, you kind of have to appreciate the sheer mind-blowing scale of it all. This four-step loop isn't just happening once or twice. It is happening millions of times a second. Literally right now, right behind the screen you are looking at to watch this. Millions of cycles, flawlessly pushing out the audio and visuals you're experiencing in this exact moment. It's actually kind of crazy to think about. It honestly just leaves you in awe of the incredible interplay between the physical body and that invisible mind of the software we just covered. I mean, the device right in front of you is a total marvel of modern engineering executing this cycle flawlessly. But it does beg a bigger, far more provocative question. If this basic four-step loop got us to the moon and put literal supercomputers in our pockets, what exactly happens when the software minds start using this exact same cycle to write their own code? Something to think about. Thanks so much for joining us, and we'll see you on the next explainer.